This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, put these off. So today we're going to be covering inheritance. Wow, that's loud. Let me just... but before we do that, I just want to cover a few things, as normal. So the module project, this course's project is now available on the LMS. The project is a big portion of your marks, and you'll see the details on the LMS so that you can review at your own leisure. The project is, as I mentioned last week, in two parts. I'll keep iterating this every week until it's submitted. The second part is a peer review, so you'll be reviewing each other's code. That is an important part of your marks, and something that you really should take very, very seriously. And I put a video up. I used YouTube just because I couldn't think of a better option. I don't know if most of you got to see it before the requirements for Friday. But if you want to have more videos, I was thinking about this as a means of sort of just touching up on some issues that some of you may have. Now, what I will try to do over the next couple of weeks is offer subjects that you may find difficult or some of you are struggling with, and I'll get my head tutor to make a poll to ask you guys what would you like me to cover, and I'll try every maybe 2 weeks or so I might try and put a small video, just a very short video explaining a particular point that may be difficult and reviewing that so that you can have an addition to your studies. If you're interested in that, when Nye actually sends you an email asking you for subject matters, then what we'll do is we'll take in all the suggestions that you give, and we'll take the highest sort of priority, the one with the most students that really want to have help in that particular area, and then I'll just throw a video together, hopefully to sort of pull together some of the more tricky sort of subjects or things that are really causing you problems. One of the things, and the reason why I was thinking of doing that was because I've been using, as you know, NetBeans, I think 8.1 or something like that for some time, and I don't like to change it during a module because it can raise other issues, and I always get worried that I'll have a problem utilizing it when I'm doing live demonstrations, which is why I bring my trusty little monitor for that purpose. But there were so many students that were having issues with just putting a class into NetBeans in version 11.1, which is the most recent one, that I decided I'll have a quick bash and see how difficult it is. And it was actually harder than I expected, because there was some little blinding issues that were silly with the newest version, which is now called Apache. It was called Oracle when I was coming up, and I think it was called something else before then. Anyway, the point I'm making is, just by me testing out what you guys were saying you were having problems with, I saw, yes, it was a little bit tricky. And if you're learning, which you obviously are, it's even more trickier, isn't it? I mean, it's really tough to try and navigate some challenging part of the development environment when that's not what we're teaching. So I'm not really teaching NetBeans, I'm just using it, right? So you could use anything. Anyway, so I just wanted to cover that. So I will get Nye to send an email around with some sort of maybe options of what you've been giving him feedback and our tutors feedback through the labs, and hopefully we can just address a few of those things in sort of finite detail and give you that kind of push that you need. So last week, we were looking at enumerated types. So before we sort of continue with this lecture, this is an important element that does need to be covered, so I will cover it. I wasn't able to give it enough time last week. So as we mentioned, an enumerated type is actually a class, but it doesn't act like a class. And it's a class designed to give you constants. So if you remember, if I give you a quick refresh, a constant is simply a variable called something my is simply okay. Oh, it's an enum. Am I in an enum? Am I? Oh. Shouldn't call the class main. I thought I was outside the main. Okay, let me rename this to something more appropriate. So there you go. So a constant, I call it const, there you go, my const, is simply a variable that you define as a final, right? So by making it final, it means that it can't be changed. We've gone through all this, and that's not what this is about. And then, of course, if you wanted to have a number of things, a number of constants, it can become quite a laborious thing. And you'll see it in code, in older code specifically. You'll see a huge list of all these constants that are being used within given projects. So obviously what an enumerated type, or an enum, does is allow you to list all the constants in one class and call upon those constants anytime you want them. And it becomes a very useful function. And in fact, the reason I want to push this forward is because you will be expected to use enums in your project. So pay attention. So as I mentioned before, an enum is a type, it's kind of like a class. I've got an example that I put together to show you in a moment. And it's simply produced in this way. You have the enum keyword, you give your variable, and then within the body of that, you just simply give the constant values. You can give those constant values, because it's a class, it's kind of like a subclass perhaps. Because it's a class, you can actually give it conditional methods, and you can give it constructors so that you can define values to each one of these. So, I mean, days of the week doesn't really lend well to having values, but if I was using a periodic table and all these constants were the symbols from the periodic table, then perhaps having the mass of each element would be a useful addition to the name, right? So that would be a situation where you might use that. So again, it's quite an important facet. So you can use them and call upon them by their value. So if I go to, I'll keep doing that. I have an enum type here that I've done as a class. I'm trying to remember which one it is now, probably this one. Oh, that's a bit too, no, that's the tester. Oh, it would be just day of the week, wouldn't it? That's the one. So here we have a basic enum. In fact, I'll tell you what I'll do. It'd be easier if I make a new enum, because that's a little bit too complex to this point. So if I make a new enum, and we'll just call it our, because it's our enum. And you can see it just produces the same structure you'd have in a normal class. But the only difference is that this keyword here, is now changed. This keyword here is changed from class to enum. Right, that's the only thing. And then all you have to do then is just to start filling this with all the constant variables that you require. So if I just put the old caps lock on and just start, you can put anything you want. So I'll just put in Bob, Sue, Kev, and all the usual three-letter names that I can think of. So now I have this enum called our enum, and it has these values that are constants. And this is the basic construct of a enum. And this can also be placed inside or inline of your code. So if we had class example, you can put the enum inside the class like this. So you've got the same construct there that you would have if you created a class, but this is a class type, and you would call it in the same way. So when you want to use an enum, you simply name it. I'll get rid of this one, and I'll utilize the one that I've just created. Oh, sorry, this thing's keeps flashing through little adverts. Anyway, so if I make a public static void main, oh, not in capitals, public static void main. And then I just say, what's the enum called? What did I call it? Our enum dot, and then you can see all the constants are there available for you. to call upon, right? So that's the enum class in that sense. It's a pretty very basic example. Going back to the slides, oh my. So they automatically have public methods, such as the toString, because it is a class type. Even though it's considered an enumeration, it is in fact a class type. So you have the toString, you can call upon the value of, etc. And then you also have this method called the ordinal, which calls the value of. So if you've got a list within your enum of certain keywords or words that you're utilizing as constants, they still have the similarity to an array, which they go from 0 to the length of the enums, so how many enums are there. And the ordinal will give you the index, if you will. So it'll return the index of that kind of value that you're looking for. So if you have, say, 10 values, and you call up the middle value, say the ordinal of 5, then you can do a comparator and see whether one is higher, lower, or equal to that value. So an enum can actually be utilized as if it is an integer by using the ordinal in that sense. So again, when you read through the project script, you'll see a reference to using enums. I would advocate that you do use them. You don't have to. If you have your own implementation, if you have your own view, your own idea of how to utilize them, to utilize the variables for the project, by all means do that. But I would expect to see enums as part of your project. So enums also have the equals and compare to. As we've mentioned before, with the equals, generally within certain objects you do have to define such things, but these are there for you to utilize. I won't drag this out more because I do need to get on with the lecture, but do start practicing and playing with enums, either inline or if you code within the same class, or making a class for the enum itself, depending on how you want to utilize that. One thing I do want to mention as well is that, oops, sorry, hang on. In enums you can actually have, because it's a class, you can have methods that you can define within the enum structure. And also the constructor can be defined also. So this is an example here just showing how, with the days of the week, as we've sort of covered, and I'll show you another example. Oh, that's from last week. But the one I want to show you is the days of the week one here. So what I've got here is the same thing. So if you compare the one I've just done here, the enum, which just has these values, right? I'll just show them like this. The difference between the one I'm showing you now is the first thing is that I've put a semicolon after the list. So if you put a semicolon after the list, it stops the list. And then from there on, because we've got a semicolon, you can then carry on giving it some variables. I've just called this one IV. Don't ask why. It was just as I was working through it, I had a glitch within NetBeans, which I resolved. And anyway, so I've created a final integer value, which becomes part of the enum. So that enum is going to store an integer along with each value within the enum. And then I've created, as you can see, a constructor that simply takes in an integer. And then I've provided an integer on creation of each enum, so that value can be stored explicitly to that given variable name, right? So that constant variable name. And of course, you can have any kind of signature you like. You can have, multiple variables within the signature profile as you need, but you just have to back them up with the variables that you're storing. And also you have to back that up by supplying the value here that you require. So if you need multiple values within your enum, this is how you would do it. So you just add commas between each value here, and obviously match that with the constructor. And then you have to also, because these are set as private, you also then have to provide a public accessor to enable you to access the values that you wish to access. Does that make sense?
Can you make it a little larger?
Oh, sorry. There you are. How's that? Any questions on that, on anything I missed? Yes?
So every amount is like an index, right? Something to go into the all of the items whatever. Enum.
So the enum, yeah,
Yeah.
has...
As an index is like an IV.
Right, yes, yes.
How many you look into every single unit or item?
Right, yes. If I understand the question, so here's an example I've got that's utilizing that same days of the week. Let me make that bigger as well. I don't know why it doesn't just default. It doesn't have a default there. So this is an example. I'm not using that one, so I'll just get rid of that one. So you've got days of the week, which is calling upon this here, this days of the week enum. And I'm calling upon different values here. So let me just try and make this more visible. I'll just, crikey. Okay, so this example here, again, this will all go online for your studies, especially towards the exam. So this is calling, for example, I've created an object, because an enum is a type, an object, you can create an object of it based on its type, so the type is an enum. I've given it a value here, and then I've said that this particular D value is of type days of the week, and then I've provided, rather than saying you don't use, the interesting thing is you don't use the new keyword, but I'm giving it the days of the week, the value of, and the variable I'm giving in this case is Tuesday. And then I'm saying, look, print out D within this print structure here. I'm printing out the value of it, which would be Tuesday. Then I'm saying and then I'm saying something, and this is where this thing comes in here. So I've got first, second, third, fourth, fifth, sixth, and seventh. And all I'm doing is I'm taking the ordinal of whatever D is. We know that D is Tuesday, so it's taking the ordinal of that, and it's putting that inside an array. Do you remember last week we did arrays? So what I've got here is the index. It's taking the value from the D.ordinal, whatever index value Tuesday is, and it's putting that into an array from this number's value, and it's just calling toString in lowercase, right? So it's basically just making all of these the same. I'll run it for you in a second. So number is obviously an enum. You can call it values, which gives you all the values in the enum. And I'm calling up the index value of Tuesday, which would be whatever Tuesday is in the days of the week enum, if you remember. Calling the toString, calling to lowercase, these are just to showcase how these things are executed. And then I'm simply making D the next ordinal plus 1, so it's going to be the next day. I'm making next value to be whatever D was, the ordinal of that value, which is whatever Tuesday is, plus 1, which will make it the next value, which will be Wednesday, hopefully, if it works. And then I'm running a bit of tidying up here with getting the length and the modulo, incrementing the modulo to get days of the week equals, again, using next, and then printing out the next value. So if I just run that, you simply get what you'd expect, right? So Tuesday is the second day of the week, and the next day is Wednesday. So that's pretty much simply just utilizing, get rid of this, utilizing the enum in code as an example. Again, I'll put this up for you. That really bothers me. And that's pretty much everything I need to cover on enums, really. Is there any questions before I move on? Now would be a good time if you want to fire anything out. Okay. So, going back to today's lecture, which is, oh my gosh. There you are. Okay. Which is inheritance. Now, obviously, inheritance is a massive part of Java and object-oriented programming. And we're going to cover a few things, such as the abstract data types. I'm going to start a class project today, which I'll run through doing some basic programming with all the kind of things that we've already learned and some of the things we're going to learn today, to give you sort of a hands-on example of how to utilize some of the things that we've covered. So the first thing we'll cover is the abstract data type. Now, so far, excuse me, so far we've covered objects, mutable and immutable. So we've covered making new objects, new classes, and instantiating, making instances of those classes. And we've covered class variables and instance variables. And we've covered methods. And what we're going to cover now, so this abstract data type is kind of, it's an interface which gives you, the programmer, a front or a guide, if you will, or an agreement with some other developer as to how you're going to program your code. It doesn't tell you what you've got to program. It doesn't tell you how you're going to program. It simply tells you what the requirements are for both the the method names, the input parameters, and the return values. That's the essential nuts and bolts, right? There's more to it than that, of course. It goes quite complex. So the interface, it hides the complexity from you, or from the clients, and you have to develop that. Now, you will be using, when you start developing in Java and you start using the Java library, you will see that many of the library classes that are available to you will say abstract. And then when you try to make a new version of it, it will say, now this is abstract. You can't do that. You can't make an instance of an abstract. So how can you use it, right? So if you've got a, what we'll do, oh my gosh, I keep doing that. What we'll do, we'll get rid of this. We'll get my little class example here. And I'm going to make, as a quick example, we're going to make an abstract class. So if I right-click on my lecture8, that's what we're on. If you look down here, we're going to have, it's an interface, it's called. We're going to make a new interface, and we'll call it new interface, why not? And we finish that, and make that bigger, like this. And essentially, what you have is a class that you're going to define variables, you're going to define methods, you're going to define input parameters and output parameters, but you're not going to do anything with them. You're basically going to cap them off and say, well, I'm not going to actually give them any code. I'm not going to code them. That coding is all up to the developer who uses this. So that's the first thing, is the keyword interface that we need to implement, right? I'll come back to this. I'll keep jumping back and forth between the slides as we go, so that I keep on track, rather than just skipping them later. So if you can't instantiate, make an instance of an abstract data type, the only thing that's left to do, or the only thing that you have to do, is that for every method within the implemented abstract data type, you have to implement that within your code, right? So it's kind of like a contract. So if I write, let's say in fact, this is probably an idea for another assessment in the future, perhaps, but if I write some code that has an abstract element, and I ask you to implement that, I give you the abstract element, then in your code, you simply implement my abstract class, and then the IDE will force you to create all the methods and variables that are required by that. If you're not using an IDE, then you'll get a million errors when you try to compile, until you've catered for every single abstract type that are within my abstract structure. Does that make sense? Anyone confused with what I just said? Okay. So again, it's designed by contract. Let's make an example. So if I make a public, let's just do void, and let's just call the class person, and we'll just do an int number. So I've just done an implementation of a basic interface type, right? And then if I go to my class example and I say implements, the name of my my class type, my interface type, you can see now it's coughing up an error. It's saying, hey, whoa, something's wrong here. And it's saying, look, I'm not sure if you can see that. Oh my gosh, I'll go here. Hello. It's saying, look, you don't override the abstracts within the class, so I've got to do something. Now, what it's asking me to do is simply, and I'll do it manually so that it sort of sinks in, it's asking me to look at this, take this, pretty much, and any of them. So if there's more of these, you have to implement all of them, right? Not just the one. So if there's many, I can make as many methods, abstract methods as I like, and I have to implement them all. Oh. So, oh my gosh. So if I make, like this, the person, you can see I've now implemented that, and then essentially it's called an override. So it gives a little message so you have to put the override symbol there. We'll cover that in more detail today. So now what that's done is I've made a contract. So when I made, let's say I created the new interface for you guys. So this is your code. I said, look, guys, I don't care how you do your project. You've just got to implement this. And I give you this interface. And all you do is that you put in the word implements and put in the name of my interface and make sure that it's in the folder, right? So it's there and available. Then essentially, I'm making a contract with you saying, look, you can invent whatever goes inside here. Anything goes inside here. You can invent anything there, but I expect this signature and this name and this return type. So those are the expectations. And this is a big part of Java. This is used throughout every implementation of Java that you'll use. You go in the library, you start using Java, you will come across abstract data types, and you will end up using these an incredibly awful amount of, of different ones, and it's essentially a way of making sure that you cater for system-wide infrastructures that you have to cater for. So, for example, when you start using threads, we won't be covering threads or multi-threads on this particular module, but when you do use threads, you have to use abstract structures to call up the expectations that are required upon you. You'll be calling methods called runnable and various other things to ensure that you're covering every part that is required for a thread to behave correctly, if that makes sense. So it's, in essence, it's a contract between you, the developer, and another developer so that you can make an agreement. And the agreement is that you will make sure that you cater for all the methods, the return types, and the input parameters, and the names as well. The names of the variables are also have to be exact. And in so doing, so I create the interface, you create the code, and in so doing, when we bring our code together, when I finally use your code, I know that your code will do exactly what I need it to do, and it will not break my system. And it's enforced within the actual structure of an interface class. Does that make sense? I still see a lot of confused faces. Any questions? Don't be afraid, honestly. It's really good to ask questions. Yes? Right, okay. That's a very good question. An interface is different. In fact, it would have been easier for you had I enforced an interface. It would have made sure that you covered. An interface is different in the sense that what you were doing, you were inheriting values that were created or utilizing values that were created as an object called checker, and you were using those methods. An interface has no control, so I don't tell the interface what it will do. I simply say what it is called and what do I expect in return. What value, what type of value do I expect in return? So there's no control, there's no statements, there's no calculations, nothing. You simply give an abstract, which is, and the key with the abstract, something to be very aware of, is this. So this semicolon, if you've ever created a method and accidentally put a semicolon at the end, you've inherently, by accident, created an abstract method that has no body. Because if you remember, the semicolon simply shuts down a line, right? It says, I've finished with this command, now move on to something else. So this is a common thing to happen, where you'll put a semicolon in your code where it isn't required. So where would you normally do that? Well, often, when you do a for loop, it's quite common to put a semicolon here by accident, right? It's just because you're used to pressing semicolon, semicolon. And by doing so, you're cutting it off, right? And again, if you're doing a value here, obviously it's giving an error now, but by putting a semicolon there, you're simply making it abstract. So the semicolon at the end, let's go back to my new interface. So the key attribute here to this interface is the semicolon, which is saying, look, this is exactly the same as a method, but there are no brackets, there is no information there, it's just a semicolon and it's cutting it off. Does that make sense? So in answer to your question, what you used for the checkers class was just a binary class file. It was almost like using your own code, except for it had already been converted with the compiler. No, that's an interesting point. So when you have if you inherit, or not inherit, when you have when you implement an interface, an abstract data type or a data structure, you have no idea what to write in the code. You don't know. That's up to you. You'll make an agreement with your pals or with your business or with the company that's employing you or whoever you're making a collaboration with. So you'll make an agreement. They'll say, okay, we don't want a return type, but we want you to take in a value, and then they'll give you something. And usually what will happen, you'll do what's called a Java doc, and you'll say something here that describes what is expected. You'll make an agreement. It's not just random. You could just end up just counting to 10 and sending them back the value. And that isn't what's expected. So what's really expected is that you make, because when you take an interface, you're kind of making an agreement either to implement, because you want to use something or you want to be part of a bigger project, and you have to make that agreement to provide clarity or some algorithm to this class that you're looking at. I think the key is you can change it as well. So let's say you and I have a project, and I give you the interface and you write the code, and then you give me the results and we work, and it works, and then I say, but it's taking 12 hours to get a result. Is there anything we can do? And you go, aha, I've got an idea. You can go back and change your code using my interface. I haven't changed anything. You can make it more efficient and return the code, and I do nothing more. So you can change the values of your code, still using the same interface to improve the performance of your algorithm, right? Or do whatever you need to do, if that makes sense.
So I'm just like building the whole building based on your information.
Yeah. It's like when you do. Yeah, that's a good analogy. I think because when you do build a building, most people expect doors and windows. So I would say, yeah, we need doors and we need windows. And today, in today's society, if you build a new building, I know back in the UK I had to do this in my own, you have to build access for wheelchairs. So you have to have wheelchair access to a building as just an expectation, right? So that would be an interface. You must cater for this. How you do that is up to you. Do you put in a lift? Do you put in a ramp? You know, do you put a catapult? You know, that's just a joke. But you know what I mean. How you implement that in the code is up to you. But the result means that, you know, you have that, the door and the window and some mechanism that's expected. Yeah, does that make sense? Excellent, good question. Any other questions? No? Okay. So this is just saying what I've said. That you have to meet the conditions of the interface. It's a contract between the implementer, which would be, in this case, yourself if you're coding, and the client who's giving you the interface. You've got to meet the inputs and outputs that are required by the contract. And then there's also an expected agreement as well. So just because if I was to change the code in my interface here, and if I was to say that this would become an array like this, then obviously this is now giving me a problem because it needs to have an array like this. And then it's expecting a return type of an array, but maybe as a contract I said I want a sorted array. I want that array to be sorted in ascending order. Now, those types of things Java doesn't cater for. So you could do assertions. So it's our job together to agree to have the assertion. Now, normally both of us, both parties, would need to put in conditions or checks to make sure that the data is the way that was expected. And Java won't do that for you unless you put in, if you remember, the assertions where you can put the testing protocols. But generally, it's your job to just double check that data is the type of data that you're going to be using before you actually use it. Now, naturally, if you're working on something that releases nuclear bombs, then you need to be pretty clear about what the data is. But if you're just doing something for a kid's party and how many balloons are going to be set off, then it might be less important for those checks to be stringent, right? So those things you do need to double check yourselves. And that leads to the concept of a design by contract. And you can put preconditions and postconditions, and those preconditions and postconditions are what I'm talking about in terms of you agreeing or enforcing certain outcomes to the values that you're passing through. So whatever value you return within that interface needs to be checked either by the interface designer or the actual the code designer. Make sense? Okay. So another central concept of Java, well actually object-oriented programming, is inheritance. I've had a few questions asking me what inheritance is and how does it work. An inheritance, it's essential for, in fact, everything that you've done so far, you've been using inheritance without realizing. So all the coding you've done for all your assessments, you've been inheriting, it's not inheriting, it's you've been taking from somewhere, how do you say it? Inheriting. Is that the right way? It doesn't sound right in my ear. You've been inheriting classes from the object class and various other aspects which we will cover. So essentially what you have when you're using inheritance is that you have a base class, the class that you're going to say this is going to be the basis of my inheritance. And this is where the object-oriented concept comes into play, that you've got to really sort of construct almost It's almost a fictional object. Now, you know, you hear of object-oriented programming, and then I show you some code, and there's just like 6 variables, and I say, there's your object. And you're like, well, that's not an object. That's just 6 stupid variables in a stupid class. How is that an object? And that's where you have to kind of invent the idea that you're looking at an object, or you're interacting with an object. So what I propose to do today is to have a simple explanation of inheritance by having a person class, and then we will have a student and maybe an employee class which inherits from person, and then we need to have a third, to go into the full depth of it, we need a third object type, that hopefully I can get you guys to throw at me. I do have an idea, if you don't, but throw at me an idea of a construct or a concept of an invention of a type that can actually be a child of a student, if that makes sense. I'll run through that in a second. So the base class is called the superclass, or the parent class, and then the inheriting class is called the subclass, or the child class, right? So you've got 2 tiers on a basic. This is a very basic concept. So you create a class which becomes the parent, and then you create another class that inherits all the methods and all the variables from the parent as the child. And the idea of this is that by doing so, you think, you're just making a copy of the parent. Well, that is true. You are making a copy of the parent, but you're then adding to your new child class methods and variables that are just specific to that child. Almost like standing on the shoulders of your parents. You learn everything they've learned, and then you go to university and you learn a little bit more, right? And then so you know more than your parents, you do more than your parents, and you know everything that they know as well. Does that make sense? So, so we basically we inherit everything that our parents have, and what that does is it means that we don't have to code it twice. So everything that your parents can do, as an analogy, you can just call upon that as if it's your class. I'll show you. When I show you an example, hopefully it'll make a huge difference. Now, in much the same way as we've used the implementation of an abstract, we use this keyword called extends to extend a base class or a parent class in the declaration. So if you had, for example, a lost person, and that lost person was extending or giving more information to a person, then you would say public class, name of your name of your child class extends the parent class, right? And then you'd write your class. There are some things that we need to cover, which I'll go into, and I'll cover those in a bit, but I'll just do a quick example now. So what I'll do is I'll make a new class, and we'll just call it person. And this is our person class, and we're just going to say it has, this person has a name. This person has, I'll just do a full name, just one name, and this person has a, let's just say an age, just for simplicity. Now, using the power of IDE, I'm just going to generate all the code that I need. And all I'm doing, for those that want to know, I noticed there's a glitch. The glitch is that when I use the, I'm pressing on my computer here, on a Mac, it's slightly different on a PC. I'm holding CTRL, I'm tapping I, which is using this generate code, and then I'm choosing what I want to generate. I want to generate a constructor. I'm going to use that constructor here. So now it's done this boilerplate, this kind of code that we do all the time. Let me, oops, make that bigger, not too big. So what I've generated is a constructor that takes in the name and the age and just stores that as the oh my gosh. Okay. If you have the same problem, the problem is that when I use the autocode generator, it stops me typing. It doesn't allow me to type. This was the same in 8.1. I don't know if it's a Mac thing. I don't know if it's just my computer thing. And the only way to make you type again is to close it down and open it up, and then I can type. Anyway. Okay, so all I've done is I've created a person. Now this is going to be my sort of parent class, okay? So the base class. We'll all use these kind of things all the time. I've told you before, I think I've told you before, one of my pastimes is I love to code video games. So I like to make video games. And I'm always using this kind of hierarchical stuff so that I don't have to recreate the wheel, if you will. So I will literally create a wheel, and then I'll have something else built on that wheel. So I'll inherit the wheel, and then I'll inherit the bike, and then I'll inherit the motorbike, and then I'll inherit, and I'll keep moving up until I have a fully fledged theoretical object that does millions of things. So you can see what I've done is I've created a person, I've given it a constructor, giving it its name and age, and that's pretty much it. So I can create its name, create its age, and then I've done these things called getters and setters, so mutators and accessors, right? So a getter is an accessor, so get the name, just returns the name. Set the name simply creates the name. And it's pretty much straightforward. So very, very basic, I'll just make it fit in, a very, very basic object. Everyone agree? Very basic, straightforward, right? So now what I'm going to do is I'm going to create another class. Oops. What is it doing? And I'm going to just create another class, and I'm going to call this student. Okay? So everyone knows that most students are people, right? I've met some that I'd question. So most students are people, some are monsters, and I haven't met many monsters since I've been at Melbourne. In fact, I haven't met any, but I have been at universities where I have met monsters. Anyway, so what I want to do here is I already have a person. I know what attributes a person requires, right? A person requires, in my very, very basic example, a name and an age. That'll do for now, right? So what I want to do is I want to extend, and I'm going to say person. Oh, person. Oh, extend, yeah. I'm dreadful. Oh. There you go. Get it to do itself. So I'm going to extend person, and it's complaining because the first thing you have to do when you actually create a subclass or a child of a base class or a parent is that you have to supply the values for the constructor. In fact, let's just make it easier. Let's go back to person here, and let's just do a constructor that has nothing. So I'm pressing Control and I, choosing constructor. I'm not ticking the boxes. I'm generating. So now it's an empty constructor. That gives me the option not to supply values, right? So very, very straightforward. I go back here. It's still moaning. No, hang on. Sorry, every time I do auto-generate. There you go. So now it's happy because it's not expecting any values. There's a constructor in the parent class that doesn't expect any values. Therefore, I don't have to call the parent's constructor, okay? Because it's automatically generated. Because you want nothing, I'll give you nothing. It's like an agreement, right? It's pretty easy. You want nothing, I'll give you nothing. Okay. So now, what I have is a person class. If I say public static void main tab, and I just simply want to use, they're public, yes. So I can now simply say, student S1 equals new student S1 dot, and now you can see I've got set age, set name, get age. Now clearly I haven't coded those in this class, have I? I haven't made any, the only reference I've made to that is this person. Now just imagine for a moment that person is 30,000 lines long, and it has 10,000 different methods that I can call upon, and 2,000 variables that I can call upon. That's the kind of power of this, is now that I can incorporate a person into this object, which I'm now calling S1, and I haven't had to create any additional code. Now, I can hear what some of you are saying, well, it's just copying it, right? It's no big deal. You're just making a copy, you're using that. Well, where the power comes from is that now a student will have its own attributes. So let's just say that a student has an integer ID. So a student has int. Okay, why is it having a problem with that? Oh, There you go. So student has a student ID. Can anyone else suggest another attribute that a student might have in addition to an average Joe on the street? Sorry, shout it. Huh? Oh, gender. Okay. Oh, okay. That's a can of worms, though, isn't it? Yeah. Okay. So we can put gender. I don't know how many parameters to put in, because up until this year, I would have put 2. But this year, I think my kids tell me there are hundreds. So I'll put in gender as a string, and you can name it anything you like. How's that sound? And that way I don't get to... So private string, gender. You're right, though. I mean, you know, I don't want to stand on anyone's toes or cause any controversy. So gender as a string, put any value you want. A very good point, gender. But then a person can be gender. I don't think, you know what I mean? So maybe gender could go into the person's value here. Would you agree? Because everyone would have the same attribute, right? Yes? So now I'll go under. I always like to go underneath here. So if I go press Control and I, I'm doing a getter and setter, and I'm just going to choose gender. So now it'll add the gender there. I will have to close this and make it big. I don't know. So now I can access it again. Yeah, very good point though. Gender was one. So just for student now, what else does a student have other than an ID? Yeah, that's a good one. A major as well, yes. So who shouted debt? Hands up, who shouted debt? You're shy now. I can't see you. Oh my gosh, okay, your hands are the same colour as the background. And I've got 2 lights in my eyes. Yes, debt. Okay, let's just put in private, it's going to be a double, isn't it? So let's put in a private debt. So now, it's a fair point. So now student 1, you can see has ID and debt. Those are the 2 attributes that it has. And it also has age, gender, name, right? So you can see how this is sort of developing. And I haven't had to utilize, I've not had to make any of the attributes of the person, if that makes any sense. Oh, that's, I don't know why it doesn't default. There you are. So let's utilize here. What did we say we were using? So the first thing we wanted to do was a name and an age. So let's just say the name of our student is Bob, and the age is 23. Oh, why is it not liking that? Have I done it the wrong way? String name, string age, and it's complaining because. Okay, so what I'll do is I'll remove this one just for, and I'll explain to you why. It's a good, actually, it's the reason it's giving an error is simply because now the name Bob and student actually don't come from the new, they're not part of the new students. They're actually part of what's called the super. And let me explain. Let me go back to the slides and show you what the super means. So you've seen how it works with no attributes. When you've got no attributes, it doesn't need any information. It simply says, I want nothing, so give me nothing. I give it nothing, and it says, hey, we're all cool, we're all happy. But now I'm saying, hey, I'm giving some values here. I'm actually providing values when I create the student. But these 2 values, Bob, and these are 2 attributes from the parent class. And I said to you, well, the parent class is now part of your class. You've inherited it. Now, that is true, but the first thing you have to do is to follow the hierarchy. So the very first thing you need to do when you're creating a new object is to generate, you have to call the superclass. Let me show you on the slides first, and then we'll go through it. Before we do that, we have this concept known as the Liskov substitution principle. What is the Liskov substitution principle? It's simply saying that, in theory, and I say that in theory purposefully, wherever you can use a person class, you can use a lost person, or in our case, wherever you can use a student, you can use a person. Wherever you use a person, you can use a student. the concept is that if one is one, the other is one, and you can. You have to be careful how you do it, so you have to still think about the way you generate your implementations. And, but in a nutshell, it's simply saying that you can utilize your person class. I'll show you examples, wherever you can use the lost person or a student and vice versa. But you have to be very careful when you design it, because you have to implement the derived classes so that it can be true. There are examples, like if you were having a base class that was a square and then you made a rectangle that was of type square. You couldn't say a rectangle is a square, even though they have 4 sides. The construct is that a square has 1 equal length of each side, whilst a rectangle has 2. So there's those sort of issues that you would come across. So you still have to think about the design to ensure that this is true, but this is a job for you guys, which is the listcov, or the LSP, as it's often going to be referred to. So it says that it must be possible to substitute an instance of the derived class anywhere the base class could be, or in other words, it must be possible to substitute the instance of a child class anywhere a parent class could be used. Right? So that's the situation. So this is the taxonomy, or the way it sort of looks in a UML. Now, we're going to cover a little bit of UML today, but we're not going to cover an awful lot. I wish we could, because UML is a very important tool, but it's not. We won't have time within this course to cover it in enough depth. So this is UML diagram looking at the hierarchy. So this here is the superclass. These are then the child classes, and these are the child classes of those. So all these 3 here, the home person, sheltered person, hospitalized person, they inherit everything of located person, and in so they're doing located person inherits everything from person. Lost person simply inherits everything from persons, right? I'm looking at the time. I've kind of run over for a break. So shall we stop quickly for a quick break? Make it a short 4 minutes, and then we'll come right back onto it. So have a quick break, guys. I didn't realise all the time. So, and we'll come back. I'll put the lights on for you. There you go. So I'll wake everyone up a bit. Yes, please.
With Java, is it just one of those things where as soon as you create a new class, you're basically creating a new file? Like most of the time, you set up a whole new file?
Yeah, most of the time, yes. That's not always true. You can put classes inside the same file.
Yeah.
We won't be showcasing that just because it does make it a little bit more confusing.
Okay.
So the norm is just to have a separate file, which is a class file. But yet, you can have one single file. Yeah. And have, all your classes inside. There's separate classes inside that file.
It's probably really bad writing, because like I've done Python before, and it's not
Yeah.
course, but like I just always just use the one file, just save everything in that
Yeah,
file.
yeah.
But that's, so obviously with Java, that's just something, well, not.
It's not impossible. I mean, it's quite common. I mean, you'll see it quite often. I don't teach that way because I think it does muddy the water with learning, because people are like, okay, well, I've got a class inside a class, or a class. Yeah. But when I showed the implementation of the enum, an enum is a class. You can just throw the class inside the class. You can do that with classes. You can put a class inside the same file.
Well, even that example that you gave just before, you had the main, you had that main.
On here?
Yeah, you had that main thing. In the student. Yeah, that public static name void.
Here?
Yeah.
Okay.
Yeah, so even that was like sort of okay, so you've actually put in.
Yeah. What you can do though is if I go to the enum test, so this is an enum test. Maybe that's not the best example. Let me.
So I guess and with the I haven't, to be honest, haven't looked at the assignment.
That's okay.
I assume that the assignment will be over a couple of different files. It's not just, you're not going to be saving simply one file.
It's entirely up to you.
Okay.
But it should how you implement it, yes, entirely up to you. So every file that you produce has to be uploaded at the same time with spaces after each one. It's in the script, so it tells you what to do. Yeah, but I never. I mean, if I give you examples, I mean, I've got an example here that I was. This is some sort of. You know, this is just one sort of structure of some files of a particular. You know, you make classes for everything that's independent. It keeps it nicely structured, really.
So you might have, for instance, false right.
Oh.
So, like, for instance,
In this,
I'm just trying to think of like what.
Yeah. So okay, so here I have a particle vector, which is the direction a particle can go, and I'll show you the code. So this is basic code of a vector. It does certain things, so it just keeps tabs of the vector. Then you have a particle system, and the particle system is, as you can see, taking up vectors. It keeps a vector for the location, velocity, acceleration, origin, etc. So that is a standard particle, but it does utilize those in terms of, I think, this one here. Oh, no. Yeah, this is it. Yeah. So then you've got a confetti. So a confetti has its own sort of attributes. When
multiple particles.
Yeah, exactly. So, but it has other attributes as well: color, shape, size, texture, that kind of thing. And for that, you extend the particle. You know, and then you've got a different particle system, which is on its own. It depends on what you want to do. But you
see how it quickly all of a sudden escalate to like hundreds of files.
Yeah, no, for sure. And this is just one small project that I was using for in this example, I was using it for a scientific project, actually. But the point being, yeah, you will use them. I would stick with files. Each class is a file. It just makes it easier to manage. And then, like I've got here, you've got this. These are all packages. So what you normally do is you put your GUI package. Everything to do with the graphical user interface would be in a GUI package. Everything to do with motion would be in the movement package. Everything to do with, and so on. And it just keeps things tidy.
Okay.
You know, that's generally how it's formed. And it's once you get into it, it becomes. It's
really well compartmentalized, isn't it?
Yeah. And then when you
breaks, it's only going to break the GUI, it's not necessarily going to ruin the confetti.
Exactly, and you can change the GUI. You can put brand new everything in there, so that you can, multilingual stuff. You can have different languages, and all you do is change the language folder. So you just simply choose the language.
Yeah, of course. You just change like an inheritance thing.
Yeah.
Because all of a sudden you just change one line of code.
And as long as as if you had an interface for those languages to cover all the constructs.
That makes a lot of sense.
Boom! You don't have to do anything. You just change the folder, and it's done. So it's, no worries. Did you guys have questions? No worries. Thank you. That's okay.
So with the previous assignment, with the checker class, I was able to open it through my ID.
You were or weren't?
I were.
Oh, good. Yes.
But then people told me, I found out later that other students couldn't, and I thought I should have.
Oh, no.
This assignment is about making a checker class, so is that violating something? Or?
No. You did right. I mean, the thing is, as far as I'm concerned, it doesn't matter how you make the code, as long as you can check it and it works and you submit it. You can use an IDE, you can use Word, you can use Nano, you can use whatever you want.
Right.
So don't fret about it.
So it wasn't supposed to be like this black box thing?
No. Anyhow you want. IDEs make it easier.
As long as mine knew, for the next assignment when I'm making a checker class, I do my own thing and whatever.
As long as you're happy. That's the bottom line. As long as you're happy.
Just wondering if it's
Nah. Not at all. No, not at all. In fact, I made a video showing people how to use their IDE. I sent it around as a circular, just because I think it's easier.
A lot of confusion there.
Yeah.
I guess I was okay.
No, good. Well done. Yes, sir.
Two questions.
That's okay.
All of the them over there, 1, 2, 3, 4, 5, 6, 7, they're simply the index number, right?
No.
No. What is 1?
Those are values that I'm giving. So here, look. So here is this here. Let me change this to number, this to number, and this to number, and this to number. So, these can be anything you want. These are values that I'm giving. These are values that I'm giving to that that's a variable.
Okay.
So, and you can do more. I can say int Bob, and then I can say. You see?
I see.
So I'll show this to everyone now just to make sure that everyone's on the same. But this is why it's good to have questions, because I wouldn't have picked up on that unless somebody asked, right?
Okay.
So you can see how that's.
Okay.
So that's actually this is actually the constructor. This is the constructor, and I'm providing values that.
For each of the.
So Monday will now contain 1023.
Okay.
Tuesday will contain 25.
Okay.
And it can be anything you want.
Can I understand in this way? Can I understand each of those days as an object of the day of the weeks? Like object Monday has 1023, like that.
Right. Yeah, it's not an object.
Yeah, but I sort of understand.
It's a not static. It's a
or
it's
like a.
It's a variable.
Variable. Okay.
It's a variable that can't be changed.
Okay.
And the values inside it can't be changed.
Can be changed.
Yeah.
Okay, cool. You can change here at the first place, right?
You can make it anything you want, but once you've made it,
it's final.
It's final.
Okay.
Yeah.
Another question, very quick. Like when you, similar as a question that I asked in the class. So when you can simply import all of the person as a library, right? Why would you inherit it? What's the difference between inheriting or import as a library? Because you are using,
I see. I'll show you as we go through the class.
Okay.
Yeah, because it's part of how it's polymorphism. It's changing. When you import, it's not much difference.
Yeah.
It's not much difference.
Yeah.
But the concept. When we start, I'll show you when we start overriding. That's what we're doing.
Okay.
Not overriding.
Okay.
And the changes is subtle, but it makes a difference. Hopefully it makes it clear.
Yeah. Thank you.
Okay, no worries. Oops. Okay. Oops. Hello. Okay. So I had a quick question, just to highlight, going back quickly on the enum issue. The question was these values that were originally here, which is 1, 2, 3, 4, 5, 6, and 7, were they the index values? And no, they weren't. So I can see why that would be confusing. They're actually signature values for this constructor. So what I'm doing is simply passing values into those constants, those constant final values that then have become part of that enum, and those values are fixed for every time you call the enum. They don't change. So if this was an elementary table and all the elements were there, all the symbols, the AU, the N, the E, whatever the elementary table values were there, you could put in the amount of neutrons, the amount of electrons, you can put in the mass, etc. You can put all those values in, and then you know that you have this fixed representation of some construct in the real world that you can call upon. So these are actually parameters that are being passed to these variables, which are then stored inside. So Monday, in this example here, Monday is now storing 10 and 23 for no reason. So don't think that there's no connection there. Just some junky values that I threw in. And if you wanted anything else, you could put in. You could put in something else. As long as you put the value in, it's okay. You know what I mean? So just to reiterate that, to make it clear, that those values were in fact variables that are being passed into the constant object. So I'm just putting it that. Let's get rid of the error. Okay. So back to where we were on the taxonomy. So this is going back through the hierarchical. This is kind of an image just detailing how it should look in a basic form. Now, generally, what I do when I'm coding, just generally, I work at the smallest level, depending on what I'm doing, and I make an object for the smallest entity. So then when I'm writing, I'm almost writing in plain English. So I'm using plain English words to define complicated structures that I utilize. The clearer you are in your constructing of these sort of hierarchical forms, the easier your code will be to both write and to read. Whilst I'm on that subject, your project, you are to be assessed on your style, on your commenting, on your use of variable names, on your use of method names. So the style in which you define and write your code is also important for your marking, just to throw that out there. Okay, so here's a quick example of overriding. Overriding is the concept that we use. So if you remember the code we had here, let me just get rid of that. You remember the code we just made with person and student? Just get them back open. Close everything else down. Okay, so let me fix this first. Let's just put it back to how it was for now, so we make it nice and easy. And put the public person. I'll fix that in a second. Oh, fix that in a second. Okay, so let's say we had something else. So say we've got these gets and setters, but let's say we had something else which was a class. Let's just call it public returns a void. This is not cool. So we've got a class that is this is not cool, and it simply does just prints out warm. I don't know. So it's not cool. It's warm. I know, it's dreadful. I'm allowed to make dad jokes. I've got 3 kids. So the point is that we've extended person, and as I mentioned before, we have all the, I'll just put S1 in there and the dots to show you. You can see all the actual methods are available, including this is not cool. So I've just created a new method called this is not cool, and it's now there. But because I've extended it, I can now make my own methods. So if I make my own methods, public void, this is awesome, like so, and this is just saying, yay, I'm awesome. Okay, so now we have that. So we can, essentially what we have, if I'm trying to get it is sort of as a concept, you have a person class which you're standing on its shoulders. You're basically taking a copy of it and you're sticking your sticker on it with all your stuff so that you can still revert back to the original if you need the original, but you can also utilize the new version, your version. So what I'm going to do is I'm going to do another public void. And if you remember, it was called this is not cool. Because, you know, in today's society, you know, warm is not where it's at, you know. It's going to get worse. I want this to be super hot. Okay? And as you can see, it's highlighted. Can you see? I don't know if you can see that, but if I zoom in, you can see it's got yellow underneath here. And that yellow is simply saying, look, do you know that this is actually covering up the original, your parents' work? Your parents spent years making that method. So your parents made, this method took them years to produce, and the word warm is significant, right? And it's saying, look, do you realize that you're actually overriding it? So it's saying, look, I want you to use the override function to make yourself realize what you're doing. I want you to be, I want you to take ownership. So a stupid analogy, I know, but I'm just trying to make it more jovial. So essentially what I've done is that I've inherited all the attributes of person, and I can also write my own methods that complement or fight against those methods from the parents' class, or I can overwrite some of the ones that I didn't like, or maybe ones that I thought, I don't need that to do what it does. I want it to do something very different, but I still need to use it. So in this case, this is not cool. You can see now, should have, it's no longer got the underline, right? So this is overriding the original version of this is not cool, right? So if I run this class, if I press S1, actually as an example, if I say this is not cool, and I just print that out. Oh. So if I print out, okay, it's not returning anything, is it? So I just have to call it, actually. Yeah, so what am I doing? I don't need to print out. So I just have to call it. If I run this now, what will it write? Right, super hot, right? But if I didn't, oh, get rid of that. Of course, if I didn't have this, and I got rid of that, and I run it now, what will it write? Exactly. So it's almost intuitive, right? It's almost intuitive. And I think that's what Java, or the writers of Java, wished it to be. I'll leave that there for now. So there is a distinct difference. Oh, you can't see that. So this is called overriding, and you've used overriding in your work. You've overridden the toString, which you should have used. Is there anything else you guys have overridden that you know of? Has anyone? What else have you used? You haven't overridden anything else? Has anyone used the compare to? Or equals? Okay, you will. Okay, so as I just mentioned, I showed that if you override anything, then the overridden value is utilized, right? But the thing to remember is, and I hope this works now, I hate doing, this is off the top of my head, but super dot, oh, I'm not sure if it's this one dot, maybe that's not going to work. Okay, that's not going to work. You can also peek in and look at the actual, I thought you could just do that. Super dot this is, okay, yeah, because it's not static. So if I make it static, this is not cool. Okay, so another thing to remember is that, it's still not letting me do it, but another thing to remember is that that of static and non-static. So if you're not creating an object, when you actually implement oh yes, when you implement a hierarchical parent, you have to be very acute of whether you're creating an instance of that object or you're not. Okay, so that, yeah. And the key, that's what I'm doing, making a cock-up. So static variables, as you remember, are actually, they're class variables, they're not instances, and therefore you can't actually utilize them in the same way. So if I was to utilize a static, if I have a static variable here in the person class, so if I make a public static string, and we'll call it Bob, just for argument's sake, and Bob equals Bob, like so. Then when I do call upon Bob, and do whatever I do with Bob, the issue is that Bob is static, which means it's not part of the object, which means even if I override it here, it creates headaches in the sense that a static object is an object that isn't instantiated, it's part of the class. So that static object remains part of the person class, and the student class, if it reinvents the static, it's not overriding it, it's actually changing it. So just something to be aware of. Right. Oh, you can't see that either. There you are. So other overridden methods, if you've used getClass, which isn't on the slide, I thought it was. So using overridden methods, you simply call the name of the method that you want to use. If you override that method, so if you write a method that matches the same signature and return type, then you're overriding. But if you only change the signature, you're actually overloading. right? So do you remember we used the keyword overloading? There's a difference between overloading and overriding. And you will need to be very clear with what the differences between them are. So to give you an example, if I have the student class, this is not cool, this is overridden, but if I type in public void this, oh, nah. I should have put an easier word to write, didn't I? So now I've got the same variable name, but I've got a different signature, so this is a different value. And this is not overriding. Even though this is the same name, this is overloading. So make sure you understand the difference. It's the kind of thing that does come up in an exam, asking you what the, whether something's overloaded or overridden. And the distinct difference is that this is now a complete new method that's written inside the child class. That has only a similarity to the parent in the name, but because Java allows overloading, it is actually a completely different method that has no reference to the original in that sense, right? Does that make sense? Okay. So you have this concept called late binding. I will so it's a complexity where Java binds the lost person with the person or the person with the lost person on runtime and not during compile time. So if you called a toString on, for example, in this example here, using the Liptov, the L principle, what was it called? The Liptov, trying to look up the slide. Yeah, the principle that where you can use one, you can use the other. If you can, in other words, you can create this construct here. So you have a person, P, equals new lost person. Because lost person is of type person, you can actually, this is valid syntax, it's absolutely fine. And then, so if I was to say, what was it? Person S1 is a new student, and then I was to say, if in student I create a toString, so I'll just do Control I, do a toString, where's the toString? There, toString, and yeah, okay, let's generate det as well. So student ID, student det, we'll give it a default. Oh dear Lord. If you have that yourselves, you'll know how frustrating it is. Equals, let's just say 1, 2, 3, 4. How much is the det? Oh, int. Oh yeah, where did that go? Int ID equals 1, 2, 3, 2, thank you. And det, I don't want to ask you. Let's just say you're in debt for $10. No, I know it's astronomical. So I'm just putting those values in there so that we can utilize this toString. So now, if I was to just system.out S1 and run that, you can see the ID. 1, 2, 3, and the value here is the debt, right? Is the amount. We can make that a little bit better in the sense that we can return a string dot format. So now you can see that I'm using a formatted string, and we're going to say student type what? Oh, ID equals, and then we're going to do the percentage, and it's an integer, isn't it? So we're going to say D, and then we're going to say comma dept equals percentage oh, no, dollar percentage 0.2 F. Will it do its D? I can't remember this. Oh, we'll do F just to see how it goes. Then we can. Oh. Right. Happy days, except for. I want a bracket there. Okay, run that again. There you go. So now we've got the actual construct for $10, which is, you recall this, right, putting in 2 decimals on a float value. So the point I was trying to make was that I've called type person, but it's actually produced the toString from the type student. So even though it's the base type is person, S1, when I printed out S1, it's actually calling the students. If I do a toString on the student, so if I go down here and press Control I, and I put in toString, I'll just let it do its thing for this one. Then, oh, I have to do that again every time. And again, when I run this, it gives just the students. Now, if I wanted to utilize the toString from the, oh my gosh, from the parent, thank you, I'd be looking at using the super keyword, and we'll come into that in a moment. Now, so just the pitfalls of overriding versus overloading. Overloading and overriding are completely different, even though they sound the same. It's a very similar word. So overriding versus overloading, distinctly different. The signature changes for which one? Overriding or overloading? Bless you. Sorry, shout again. Overloading, exactly. So the signature changes for overloading. And that's the same if the signature changes, even with the same name, it's overloading. Just be aware of it. It is a common thing that we will be covering when we're assessing. And usually, you don't really type in overloading. When you overload method, you don't write the word overload at overload. So generally, overriding is what you'll want to be using most frequently when you're using inheritance. So now we have this construct of visibility. Keep tabs on the time. So you know about the private visibility and you know about the public visibility, right? So private hides the values from any external class, and public allows you to see them, right? So we went through this a few times. We also have this construct called protected. And a protected, it's interesting because it's not very protected, really, but we'll go through it anyway. So a protected type is similar to, it's similar to the public and private in the sense that you use it to sort of safeguard or to alter the visibility of your code to outsider classes and outsider developers. But it is a misnomer, meaning that even though it says protected, it's not protecting anything, right? As I'll show you, there's only one instance of where it is actually protected from. Everything else can see it. But essentially, so if I have the gender, no reason for the gender, just because. So it's protected. It still allows you to utilize the gender. You can still access that, and you can still utilize that, even if you put in, even if you change the there you go. So even if you change the, what is that, get gender. So we're going to say we're going to protect the get gender, that variable. And even then, you should be able to still get gender. As you can see, it's actually not well protected. And that is because as the slides are saying, all you have to do to access it is to actually create a subclass. So if you have a protected element, which essentially protects what it does is it protects the parameters, the variables and the methods from other I forgot the word, packages, that's the word I was looking for. So from other packages. So essentially, if your class is inside another package, it cannot see the protected parameters, it can't see protected methods from another package. And as much as that's useful, I personally, honestly, I can tell you with hand on heart, I have probably used protected keyword. Never, actually. I just don't use it. I either use private or public because that's just how I code. It has a functionality, and maybe it's because the teams that I've worked with haven't felt that this is a priority. It isn't something that we've needed to use. Yeah, but it's there, all right? So you need to know about it. And then not to say that you shouldn't use it. I think you probably should. So to be able to access that, all you have to do is to create a subclass. So in another package, you can't see, you've got two packages, package 1 and package 2, and you can't see any protected element from package 1 that's in package 2 or vice versa. But if you just create a subclass from package 1 or vice versa, then you can see it. So that's really weak protection. But that's what it does. It basically protects it from that one scenario. So you've already covered packages. Now, I don't want to dwell on this too much because I'm asking you not to use packages. Packages cause a problem with the submit system. And we could overcome that and ask you to do more complicated things, but to keep it simple, as a rule, we will not be using packages for submissions. Just be aware of that, okay? But I will cover it just so that you understand. So a package, all a package is a folder. That's it. You know everything you need to know about packages. Now, it's a folder that your code is put inside, and when you run your code, if it isn't inside that folder, it will complain. It'll say, I can't run. I'm not inside the folder you said I'm in. You said I'm in package Bob, and I'm not in Bob. So it'll just complain. So it's just a way of keeping order. So the package simply is a folder that you keep your work in. And the reason that's difficult for us is because we want your code to be outside of a folder, so we don't want it in a package. And protected members are visible in all classes in the same package, but not in any other package. There is a fourth visibility called default, or friendly, or package visibility, and that's when you don't define anything. So if you don't put private, public, or protected, it simply becomes default. And default has its own visibility as well, which I'll showcase to you now. In fact, I'll skip on to this one. So this is a UML diagram is it the right colours? Yes. Okay. A UML diagram that simply showcases how we look at classes in UML. So UML is a markup language that shows you the structure of your code. Really useful, I mean, really helpful to see what's going on, especially when your code starts to get complicated. And honestly, you know, your code can be as complicated as you can think. So, and what we have here is in the blue squares, this is the package, this is the folder, right? And then this big square here is the class. The class name is A. Then this next square, so you can see there's 1 square, 2 square, and 3 square. This first square is the name of the class. The second square holds the instance variables, so there'll be all the variables that form the object of the class. And then the last one here would be the methods. So if you have the method names, that's where they would be here. So in UML, we have these symbols in Java that represent, so plus is a public, the hash symbol is protected, the tilde is a package, and dash is a private. So this is the sort of key for those. And then these arrows, the open white arrows, these are defining subclasses or children, right? So this A is a parent class. B is inside the same package, but is a subclass of A. C is inside the same package, but not a subclass. D is in a different package, just doing its own thing. And E is a subclass of A, but inside a different package. And essentially what you have is that A sees, so what A sees is everything, right? Because you can't hide anything from yourself, right? I was going to make a joke and say, look, you've all been in the shower, you can't hide. You have, A can see everything. B, which is this one, can see the public, protected, and package, but it can't see the private. C can see the public protected package. D can only see the public, right? So D can only see public. And E can see the public and protected. So you can see that everything can see public. Everything but D can see protected, which is why I was saying it's not very protected, is it, really? All you have to do is to make an instance of any class and you can access all the protected methods, which is why I tend not to use them, because it just opens up a can of worms. Packages can only see what's inside a package. So A, B, and C can see what's inside the package, obviously, and private can only be seen inside. Oh, it's time to get up. Does everyone hate that sound? It's the same sound here I wake up to every day. Anyway, so any questions on that? Otherwise, we'll just move on. So this is the visibility of essentially private package, public protected package and private, right? Package being the folder that it's in, protected simply being this weak-ass protection that doesn't really work most of the time. So essentially, I would advocate, look, honestly, private and public are the ones you'll likely use. Use public only when you need to. If you feel there's a good need for protected, that you see the use for it, then use it. Like I said, I just haven't had the, I'll say the opportunity. Okay, so quick, we'll just do a quick little one of these just before we probably end up calling it soon. So if you go on your devices, go to this location. I expect you've all got it now on your favorites, right? And this is just so the question, move this out of the way. Which classes can access method M? So we have package 1, package 2, package 3. You have a class C1, class C2, class C3, class C4 in package 2, class C5 in package 2. And then you have this M. This is a method called M. The question is, which classes can access method M? Have a little think. Have you all cast your vote? Random chance? You get a 20% chance of correct, no matter what you choose. Okay, ready? Say yeah if you're ready. Yeah, good enough for me. Oh, there you are. Right, so the majority of all 36 of you is E, with a few on D, less so on C, and obviously nobody thought A. Interesting. Just double check that. Oh, more people are coming in. Okay, right. I'm surprised. So again, Homer's there to protect me, not to protect you, because often the actual answer is C. Right. So woohoo. It's C. Now, we are running out of time, so I will let you review that in your own time rather than going through it in detail. But the answer is C. This is a package method because it has no construct of protected, public or private. So I'll let you review that, review the slides, and we'll address that next week. So just to recap, you cannot override a method giving it less visibility. That's something that which we need to highlight. What does that mean? It means that if you've got, for example, a public method that you're overriding, you can't then say, oh, I want it to be private. If you're overriding it, you can only make it more visible. So if you had for example, if you had sort of a protected value, I think so down here, you've got the private being the most protected, default being the sort of next one down, protected being less, and public being less so. Now, essentially what it's saying is that you can only move to the right and not to the left. So if you've got a value that's default, you can't move to make it private, but you could make it protected or public. If you had a protected, you can't move default or private, but you can move it to public. Does that make sense? Right, it's turning 4 o'clock now, guys, so I'm going to call it there. We will continue with this next Monday. I will speak to Nai to enable us to find out if you need any more little snippet videos. If you feel that they were useful, I'd be happy to make little videos to kind of guide you on certain constructs, go into a little bit more detail, keep them very short, keep them brief. And with that, have a look at the project, and I'll see you next Monday. Thanks, guys.